Actual.
Hello guys, I'm here, of course, up at the school trying to record for you. Hopefully it goes pretty quick and I can get this recording uploaded for you. Alright, this lesson is going to be on irrational numbers, and let's start off by talking about squared numbers. That's what it comes back to. Squared numbers just mean something to the power of 2, or you could say 5 to the second power. There we go, which is 25, which is 5 times 5. Or you can say 5 squared, and it's called a square because it actually creates a square when you draw it out, when you do a 5, 5, 5. And that's why it's called 5 squared. And pretty much any number you do will come out to exactly that. 6 times 6 is 36, and so forth. 10 squared is 10 times 10, which is 100, and all of these would actually make a square. And if you look at it here, if you go 5 times 5, you're actually looking at the area of the square, which is also known as the s squared side by side. In this case, it would be 5 squared, which is 25. That means that the area in here that it covers is actually 25. All right, those are squared numbers. Now we're going to try to work the opposite direction. We're going to go back to the square root of a number. Oh, I completely messed that one up. Let's start here. I'm going to put 5 as my whole number, and then I'm going to go square that 5, which we just said was 5 times 5 is 25. I'm going to take the square root of 25, and I come back, and my answer is 5. Okay, let's do that again. Here's my 6. 6 squared is equal to 6 times 6, which happens to be 36. Take the square root of 36, which is 6. All right, let's look at that. Square root, it means we're going back to the root. If you look this way, it actually is going back to the original number we started with. That's the root. It goes back to the root. Think of a plant. The roots are at the bottom where it starts, and that's exactly what we're doing. So all of these that have a whole number answer, those are actually called perfect squares. Perfect squares. So let's just start real quick. Let's do this. So 1 would be the square root of 1 is 1. The 2 squared would actually be 4. So square root of 4 is 2. 3, the square root of 9 would be equal to 3. 4, the square root of 16 is equal to. All I'm doing is when I'm to figure this out, I'm squaring this. 4 times 4 is 16, 3 times 3 is 9, and so forth. I want to do a few more real quick. I got 5. That would be the square root of 25. It's actually equal to 5. Now, do not mistake this. I actually shouldn't do this. Let's call this a number line. This is a number line. Do not mistake my number on top of that as being division. Absolutely not. It's just a number line. So here's my next whole number. And that could also be represented down here as square root of 36. Then if you go, and this is 7, square root of 49. Keep on going, that's 38, that would be square root of 64. In other words, you can write these numbers on the number line in different formats, and that's basically what we're doing. Now today, your lesson, the whole thing at 8th grade level that we got to look at is what happens to the square roots that are in between. The square root of 2 is in there, square root of 3. Those two numbers are in there, so they don't have perfect squares. Over here I have a square root of 5, square root of 6, square root of 7, square root of 8 that fall into this section here. The question is, what are those called, or what do we do with them? They are actually called irrational numbers, which is what this whole lesson is about. This here has quite a bit. It goes square root of 12, square root of 13, all the way to square root of 15. All these are in there. All right, so our lesson will be on trying to find out the value of an estimate. These here are perfect squares. Now the ones in between are irrational numbers, and this is 5. And if you look at this, start a little bit lower. Let's talk about the square root of 3. The first thing I got to do is determine which two numbers it falls between, which two perfect squares. Now I know 2 comes down as the square root of 4, and I know 1 comes down as the square root of 1. So the question here would be, what's in the middle of 1 and 2? How about 1.5? Because we read from left to right. So your next question would be, which one is it closer to? So what I like to do is say, if you want away from over here, it is 2 away from over here. And you just figure 4 minus 3 is 1, and then the 3 minus 1 is 2 away from there. Definitely closer this way, which means my estimation, and I'm talking It's a rough estimation. I'll never know the exact answer. That's why it's an irrational number. It's going to be above 1.5. So I could estimate 1.6. I could estimate actually kind of high. I would give you credit for that because right now we're just talking about estimation, and in class we talk about how we can get pretty accurate. 1.6, but since only one away, I'm thinking it should be pretty high, maybe 1.8, possibly 1.9. Let's do one more, and then we can talk again. Let's see, how about the square root of, what do I want to do? Square root, Brandon, give me a square root of 1 to 10. Give me a number, 9? All right, Brandon said square root of 9. So I got to figure out which, that's not going to work. We wanted one between, give me another one. All right, he changed it up, which is good. He said square root of 6. I guess square root of 9 would work too. That would have been a perfect square. Let's do the square root of 6. We want to practice these irrationals. Okay, so I know that it falls between the 9 here, which happens to be a 3, and then the 2 here, which happens to be a 4. The next question I ask myself, which one is it closer to? It is 3 away this way, 2 away this way. So definitely above my 2.5 mark, that way. So for now, all I want, and here's my estimation equals 9, something above 2.5. And it's coming over, and you could figure out which are the half up there, but we'll talk about that later. Right now, I just want you to estimate above the half or below the half. So here I'm going to call this about 2.7, and we'll talk later about how we can check if it is or not. All right, I took a little bit long. I do apologize. I will see you next time. Actually, we look at the next little section. I will do some examples of your homework. All right, talk to you later. Bye. Bye.